So we went over the standard units for length, mass and weight, and then capacity and volume. I want to go over the metric units next. Before we talk about metric units, I want to talk just briefly about the metric system as compared to the standard system. The standard system is what we call an evolved system. It developed from a necessity, like we talked about, that need to communicate. And then you had all these different units. People use different things to measure. And then at some point, we finally tried to force them together to make them work together. We did adjustments over time and whatever to develop a system. But the standard measuring system was never intended to be a unified system. We forced it to become a unified system. We had to adjust lengths and sizes and stuff to make things fit together to convert. But it was never designed to have a meaningful conversion from one unit to another. And that's because they didn't really think about it. I mean, they just, as it was needed, they changed the system and altered the system to make it work for what they needed. The metric system was developed in the late 1800s, in the late 1880s and 1890s. So it's only been around for about 130 years at this point. And the metric system, they had the benefit of having watched the standard system literally for thousands of years. They saw the things that worked well in it. They saw the things that did not work well. They saw the things that could very easily be improved on, things that could be adjusted to make it simpler. So when they created the metric system is a designed system. So like I said, the standard system just evolved. And if you think of evolution in animals, you can see some pretty crazy things that evolved that really don't make sense. The same type of thing happened with our measuring system. Some things evolved that really don't make sense, but there was reasons behind why they were done that way. The design system and the metric system, they were able to design and get rid of some of those things that didn't make sense or some of those things that were difficult. For example, for each type of measurement, there is only one unit of measure in the metric system. For length, they use the meter. Now, a meter is actually slightly longer than the standard yard. I should say slightly longer than the English standard yard. I've thought many times, wouldn't it have been really nice if the meter were just the same size as a yard? It would have made it really simple. Well, as I mentioned, I didn't realize this till years after. As I mentioned, different areas had different rulers that standardized their sizes. Well, the metric system was designed in Switzerland, and the meter is actually equivalent to a Swiss yard. For capacity, they use a liter. Again, a liter was just a unit they developed. And actually, there is a link between length and capacity here. We'll talk about in a little bit. Now, don't be surprised if you see meter spelled M-E-T-R-E. More common is liter, L-I-T-R-E. Those are the European spellings of those. And you do see them in some literature in the United States. For mass, they use the gram. A gram's a little bit bigger than the size of a small paper clip. So fairly small in size. And for weight, most people have never heard of this one. There's a Newton. We will not use Newtons in this class. We're going to focus on the meters, liters, and grams. Abbreviation for a meter is just the letter M. For a liter is the letter L. Now you see me use the capital L all the time because when I was learning the metric system, I learned the metric system in the mid-80s. We were told that you had to use a capital L to abbreviate liter. The reason they did that was in many of the typewriters at the time, the number 1 and a small l were indistinguishable. In fact, some of your really old typewriters, way before my time, didn't have a 1 key on them. Just used a small l for a 1. With modern type fonts now, the 1 and the small l in most type fonts is unique, so you can tell the difference. So it is okay to abbreviate liter with a small l. You just don't see me do it because I'm used to the capital. Also, my small l and my 1 both look like that. I don't want you to look at this and say, is that 5 liters or is that 51? So by making that a capital L, it's very clear that's 5 liters. So I'll use a capital L when I abbreviate liters. Grams is abbreviated with just a G. Be careful with this one because occasionally you see this abbreviation, GR. Does that stand for grams? It doesn't. That stands for grains. So it's not even the same measuring system. Okay. Newton is just a capital N. It's the abbreviation for Newton. Outside of physics and engineering, you don't see newtons really used. The metric system really doesn't look at force or weight. They just look at mass. Which makes it really weird because the standard system focuses on weight rather than mass. So when we do conversions between systems, we'll actually be converting a standard weight to a metric mass, which is very sloppy, but that's what the different systems focus on. So we make that conversion. So what if I need to measure something that's way smaller than a meter or way bigger than a meter, or for a liter or a gram for that matter? Well, we have prefixes. So we've got our meters, our liters, and our grams in the middle here. If I want to go smaller, there's a prefix deci. Deci means 1/10. So you have a deciliter, decimeter, decigram. Would be 1/10 of a liter, 1/10 of a meter, 1/10 of a gram. Next is the prefix centi, which is 1/100th. So a centimeter, centiliter, or centigram is 100th of a meter, 100th of a liter, 100th of a gram. And then this one pops up again, milli. Remember, mil was 1,000, milli is 1/1000th. So a millimeter is mm, milliliter is ml, milligram is mg. That's 1,000th of a meter, 1,000th of a liter, 1,000th of a gram. Now you can see here they went every 10. We went 10th, 100th, 1,000th. They stopped doing that at this point. So we skip from 1,000th, we skip the 10,000th and the 100,000th, and we go up to the 1,000,000th. That is micro. The abbreviation for micro is the Greek letter mu. Looks like that. Looks like a U with a long tail on it, or a P that they don't quite close the top of. So like micrometer would be mu m. Microliter, mu l. Microgram, mu g. Now, one of the few fields that uses micro, usually microliter or microgram on a consistent basis, are the medical fields. And the medical fields is one of the first fields to have to keyboard everything into a computer system. And there is no key on the keyboard for mu. So rather than having to go into a symbol menu every time they needed to keyboard that in, they use MC as the abbreviation for micro. So MCM would be a micrometer, MCL would be a microliter, MCG would be a microgram. So if you see any of those, it stands for micro. And then, of course, they didn't do, the 10 million, 100 million. They skipped up to a billion. A billionth is nano. We're not going to deal with nano in this class, but I wanted to mention it. Of course, I wrote that so you can read it. It's kind of faded a little bit in the last few years, but 4 or 5 years ago, you were hearing a lot about nanotechnology and nanoscience. All that is the science of things that are really small. A nanometer is about the size of a single atom. So they're talking about, when they're talking about nanoscience and nanotechnologies, they're talking about building stuff from individual atoms rather than from larger pieces. And there's a lot of really weird things they can do if you get down to that size. They do this with medications. There's they call them nanomers. They're nanoparticle molecules that are set up for like different medications. You can take one pill and it'll release different medications over time. Like it might start out by releasing a painkiller, and then over time it'll release, an hour later it'll start to release a medicine that treats your condition or whatever, and might release a relaxant or whatever. It's really kind of weird because you have several medications in a single capsule, and it releases different ones in different concentrations over time. So there's a lot of science in there. That's when they talk about nanoscience. That's what they're talking about, just really tiny things. Going larger than a meter, liter, or gram, we have deca. A deca means 10. Now, since DL, DM, DG were already chosen for deci, deca is abbreviated DA. So DAM is decameter, DAL is decaliter, DAG is decagram. That's 10 meters, 10 liters, or 10 grams. Next comes hecto. Hecto is 100. So a hectometer is 100 meters. Hectoliter is 100 liters. Hectogram is 100 grams. One that's going to be a little more familiar. Kilo is 1,000. Kilometer. Closest thing that we have to a mile is km, is 1,000 meters. Kiloliters don't get used that much. A kiloliter would be like 270 gallons. It's a little bit large, but it's 1,000 liters. Kilogram is what we typically use if we're trying to measure weight in the metric system. However, kilogram is a unit of mass, not weight. There is no 10,000 or 100,000 again. We skip up to mega, which is 1 million. So mega is a capital M for the abbreviation. So capital M, little m is a megameter. Capital ML is a megaliter, and capital MG is a megagram. A megagram actually has another name. It's often referred to as a metric ton. It is 1,000 kilograms. So they don't think of the mega, they don't really think of it as 1,000,000 grams. They think of it as 1,000 kilograms, which is the same thing. 1,000 is a million, but they call that a metric ton. Now, looking at these, some of you might be thinking, well, we haven't heard of most of those before. And that's because they don't get used much. For meters, liters, and grams, the main units get used. Kilo gets used. Hecto and deca tend to not get used hardly at all. Hecto gets used for measuring land size. We didn't even talk about an R, which is a unit of area. Like acres for land in the standard system, they use an R for measuring land size. We're not going to discuss those. A hectare is 100 R, and that's about the only place the hecto prefix gets used is for land measurement. On the other side, milli is the one that gets used the most. Milliliter, milligram, millimeter. Now in the United States, centimeter gets used a lot. Only because centimeter is the closest thing to an inch in the metric system, and the inch is so ingrained in us, we tend to use centimeters for stuff. But if you go outside the United States, they use the millimeter way more than the centimeter. Let's see, in deci, the only thing that really gets used there is deciliter. That only gets used in the medical fields. If you ever have a cholesterol test done and it comes back of a 190, that's saying it's 190 milligrams of cholesterol per deciliter of blood. Or you do a blood glucose test, a blood sugar test, and it comes back as an 87. Again, that's 87 milligrams of blood glucose per deciliter of blood, is what those tests are measuring. Conversions in our metric system are really kind of neat, because you see every spot on here is either multiplying by 10 if I'm going this way, or dividing by 10 if I'm going that way. Well, if I multiply by 10 or divide by 10, all it does is take my decimal point and moves it one spot, left or right. So actually, this chart does the conversions for me. If I have 270 centimeters, I want to convert it to meters. I am going from centimeters to meters. So I look at my chart, I'm going from centimeters to meters. I have to go 2 spots to the left to do that. My decimal point's right here. I have to go 2 spots to the left. 270 centimeters is 2.7 meters. If I have 43.6 kilograms, I want to know how many grams that is. I'm going from kilograms to grams, so from kilograms to grams, I got to go 1, 2, 3 spots to the right. My decimal point has to go 1, I have to add zeros, 2, 3 spots to the right. It's 43,600 grams. If I have 490 milliliters, I want to convert to centiliters. Well, again, I'm going from milliliters to centiliters. From milliliters to centiliters, that's 1 spot to the left. My decimal point, starting here, goes 1 spot to the left. That's 49 centiliters. So it really is just a matter of having that chart and then moving your decimal point according to that chart. So, the big question now then is, since both systems exist, going from one system to another. So let's look at converting metric to standard, or standard back to metric. We'll start out talking about length. In the length system, there's only one conversion that I have memorized. That's 1 inch equals 2.54 centimeters. That is because that one is nearly exact. Now I can derive my other conversions from that. For example, let's say I want to convert, what's 1 meter is how many yards? I want to figure that out. So, if I want to figure out how many meters are in a yard, or what's the relationship between meters and yards. In fact, what I'm probably going to do is I'm going to find out that 1 yard is how many meters first, and I'm going to work backwards. 1 yard is how many inches? Careful, 1 foot is 12 inches. 1 yard is 12 times 3, right? 36. So here's what I'm going to do. I have this equation here, 1 inch equals 2.54 centimeters. I multiply by 36. 1 times 36 is 36 inches. 2.54 times 36 is 91.44 centimeters. 36 inches is 1 yard. 91.44 centimeters. To convert that to meters, I'm going 2 spots to the left on my chart. So I move 2 spots to the left. So it's 0.9144 meters. So 1 yard is 0.9144 meters. If I wanted to go the other direction, 1 meter, well, I'd divide both sides of this by 0.9144. So 1 divided by 0.9144, 1.094 we'll call it. So 1 meter is 1.094 yards. Most often, I believe this book calls it 1 meter is 1.1 yard. I believe is where they call it. Well, let's look at this again. 1 yard, 0.9144 meters. 1 mile is 5,280 yards. Let's multiply by 5,280. So 1 yard times 5,280 is 5,280 yards. 0.9144 times 5,280. Perfect. 4825.92 meters. Now let me try that again. 9144. 4828.03. That looks better. Thank you. .03. I multiplied by the wrong number there, didn't I? What should I have multiplied by? 5,280 feet in a mile, not yards. 1,760 yards. So it should be 1,760 times 0.9144. There you go, 1609.34. Hopefully put my decimal in the right spot. So there we go. So what that is saying is 1,760 yards is 1 mile. To get from meters to kilometers, is 3 spots to the left on the chart. So we move the decimal point 3 spots to the left. That's 1.60934. We'll go 1.609 meters. Kilometers, I should say. 1 mile is 1.609 kilometers. I believe the textbook just says 1 mile is 1.6. Close enough. So we can get those conversions just by using that 2.54 centimeters in 1 inch. For capacity, I know that 1 gallon is 3.785 liters. So let's say you have an 18-gallon tank on your car. How many liters is that going to be? Well, 18 gallons over 1. We'll put gallons on bottom, liters on top. 1 gallon, 3.785. Gallons cancel out. It's 18 times 3.785. 68.13, you are correct. So it's a little bit over a 68 liter tank for an 18-gallon tank. When we get compound units, remind me, I'll do that conversion of if gas is, 230 per gallon, what does that come out to be per liter and stuff like that. If I want to look then at some other conversions, like say I want to do a quart to liter. I believe the book, by the way, does 1 gallon is 3.79 liters instead of 3.785 liters. If I want to do the quart equivalency here, 1 gallon is 3.785 liters. Well, 1 gallon is 4 quarts. So then to make that equal 1 quart, what do I have to do? Divide by 4. Divide both sides by 4. 1 quart, 3.785 divided by 4. 0.9463 we'll call it. Liters. For weight and mass, like I had mentioned before, this is where it gets kind of sloppy because we use that 1 kilogram is approximately, I should use this, 2.2 pounds. And that's what we use for our conversions. Now, to do these conversions in your textbook, I've got it down as page 576, but that might be the old edition. Should be close to that, though. Here it is. This is actually still on page 576. Really good. On page 576 in your textbook, there's a bunch of conversion factors, metric to standard. And they actually just call it US. So they go US to metric, metric to US. When you are doing these conversions in my math lab, let's say you are given 140 pounds and you want it converted into kilograms. You can look that up and there's going to be 2 different conversions given. One is going to be 1 kilogram equals 2.2 pounds. The other conversion is 1 pound equals 0.454 kilograms. How do we know which one to use and will it matter? Well, the answer is in real life it doesn't matter, but in my math lab world, using the wrong one could put you outside of the round-off errors. So the way my math lab decides which one to use is by making the calculation easier. We have 140 pounds here over 1. Let's not put any numbers in here. What has to go on bottom? Pounds or kilograms? Pounds, so they'll cancel out. So kilograms have to go on top. In my math lab's world, it's easier if we don't have to divide. So we're going to use the equivalency that has 1 for pounds. That's going to be this one. So 1 pound is 0.454 kilograms. So that's 140 times 0.454. 63.56. The pounds have canceled out, they're gone. So by keeping 1s in the denominators, you don't have to divide. It would not be incorrect in my book. The 140 pounds to me it would be just fine if you said 1 kilogram is 2.2 pounds. Unfortunately, 140 times 1 kilogram is 140 kilograms. 1 times 2.2 is 2.2. 140 divided by 2.2 is going to be 63.64. You can see really, really close to the same. It's just round off errors is all it is, but my math lab will not accept this answer. This is just far enough outside the round off error to not accept it. So when you are doing these in my math lab, make sure you set up that conversion factor so that 1 is in the denominator. So if I have 27 meters and I want to convert it into feet, well, I look up, I have 1 foot is 0.305 meters, or I have 1 meter is 3.28 feet. So I look at this, 27 meters over 1. I'm going to put meters on bottom so they cancel out, feet on top. Which one of these do I need? The 1 foot equals 0.305 or 1 meter equals 3.28? I need the 1 here with the meters. So I need 1 meter is 3.28 feet. Always choose the conversion factor that's going to put 1 in my denominator. So that'll be 27 times 3.28. 88.56 feet. Again, the other way would not be wrong. 27 divided by 0.305. It's just going to give us 88.52. I believe my math lab might accept that one because it's close enough within the round-offs, but it might not. So my math lab is looking for this answer, the one that puts a 1 in the denominator of my conversion factor. So be aware of that. Next, I want to talk about the 1 unit of conversion that is not able to be done by a simple conversion factor conversion here. And that is temperature. Temperature we tend to gauge off of water. We start with the temperature at which water freezes, the temperature at which water boils. We have our Fahrenheit scale, which I'm just going to do degrees F. It's our standard scale, and then we have the Celsius scale, degrees C. This is the metric version. In our Fahrenheit scale, what temperature does water freeze? 32 degrees Fahrenheit. I'm going to say over the winter we encounter that a lot. Freezing and below freezing. Anybody remember what temperature water boils in the Fahrenheit? 212. Really good. Not many people know that one anymore. We used to have to memorize that one when I was in school, but we tend to have lost that one. On the Celsius side of things, what temperature does water freeze? 0 degrees Celsius. And water boils? At 100 degrees Celsius. So you can see 1 degree Fahrenheit is a different size than 1 degree Celsius. From freezing to boiling, 212 minus 32 is 180 degrees on the Fahrenheit side. On the Celsius side, 100 minus 0 is 100 degrees on the Celsius side. So you can see a degree Fahrenheit is actually smaller than a degree Celsius. That ratio, by the way, is important. 180 over 100 is 9 to 5. Or if we did it the other way, 100 over 180 is 5 to 9. The problem is, it's different from any other type of measurement, weights, lengths, capacities, whatever, is there is no common 0 point. For length, 0 centimeters equals 0 inches equals 0 feet equals 0 meters equals 0 yards. 0 is 0. For capacity, 0 liters equals 0 gallons equals 0 quarts equals 0 milliliters. 0, 0. 0 grams equals 0 pounds. I mean, there's a common 0 point. For temperature, there is not. Therefore, for temperature, we cannot use the simple conversion factor. We have to use formulas. So to go from Fahrenheit to Celsius, if we know the Fahrenheit temperature, first thing we have to do is account for that difference in 0 points. So we subtract 32, because 0 degrees Celsius is 32 degrees Fahrenheit. Then we multiply by that ratio, 5 to 9. That's the difference in the size of the degrees. So that 5/9 then gives us the degrees Celsius. So let's look at human body temperature, 98.6 degrees Fahrenheit. Let's convert that to degrees Celsius. So it's 98.6 minus 32. (98.6 minus 32 is 66.6. 5/9 times 66.6 is 37 degrees. So it's 37 degrees Celsius. If I want to go from degrees Celsius into degrees Fahrenheit, it's actually the exact opposite. I start out with my degrees Celsius. I'm going to first multiply by, instead of 5/9, 9/5. Then I'm going to add back on that 32 degree difference. So let's say you're listening to the radio this morning and the weather person says it's going to be 25 degrees Celsius today. Is that a nice day or not? Well, let's plug it in. 9/5 times 25 plus 32. Well, 9/5 times 25 is 45 degrees. Plus 32, that's a 77 degree Fahrenheit day. That's a pretty nice day. I'll take that. Any questions? Okay. We're going to cut a little bit short of time on this next part, but I do want to start talking about it just because it's important to have it out there. Areas. Our unit of area in the standard system is a square inch or a square foot. A square inch is defined to be 1 inch by 1 inch. That's 1 inch squared. A square foot, obviously not drawn to scale, is 1 foot by 1 foot. That's 1 square foot. Now when we look at this, 1 foot is 12 inches, correct? So 1 square foot is 12 inches by 12 inches. That's going to be an area of 12 inches times 12 inches is 144 square inches in 1 square foot. So the conversions change when we start talking about areas. In the metric system, we might talk about a square centimeter. 1 square centimeter is 1 centimeter by 1 centimeter. Or 1 square meter. Again, not drawn to scale. 1 meter by 1 meter. But of course, a meter has 100 centimeters in it, right? So that's 100 by 100 centimeters. So the area of that, 100 centimeters by 100 centimeters, is 10,000 square centimeters in 1 square meter. We have to be careful with that. Any questions? That will be in my math lab, and we will talk more about it on Wednesday. Volume. Same thing. For standard, all right. 1 cubic inch or 1 inch cubed is defined to be 1 inch by 1 inch by 1 inch. One cubic foot or 1 foot cubed is 1 foot by 1 foot by 1 foot. Of course, that's 12 inches by 12 inches by 12 inches, which is a volume of 12 inches times 12 inches times 12 inches, or 1,728 cubic inches equals 1 cubic foot. So we've got to be aware that those conversions change. Okay, we don't really have time to get into too much detail with this right now, so we're going to call it a day right now. We will go over this more on Wednesday, and we'll talk more about dual units on Wednesday. There is a quiz from we had a test last Thursday, isn't there? So there is no quiz, so all you have to do is a new homework. It'll be due Wednesday. Have a good week. We'll see you on Wednesday.